In this video, we're going to look at how to derive the slope of an indifference curve, and I'm going to use the technique of the total differential. So here we have a utility function that is a function of good x and good y. The total differential showing the change in utility, du, the change in utility, equals a partial derivative of the utility function with respect to x times the change in x plus the partial derivative of the utility function with respect to y times the change in y. So here again we're just decomposing the change in utility. The first partial derivative can be thought of as the marginal utility of good x, the change in utility from consuming one more unit of good x, and the second partial derivative is the marginal utility of good y, the change in utility from consuming one more unit of good y. So to get the slope of the indifference curve, we recall that along an indifference curve, utility doesn't change, so du, the left-hand side, is 0. And now I'm just going to solve this for the slope. And since we're graphing an indifference curve in a yx plane, where good y is on the vertical axis and good x on the horizontal axis, the slope would just be change in y, delta y divided by delta x, or in this case, dy over dx. So I want to solve this equation here for dy over dx, and that'll be the slope of the indifference curve. So first thing I do is move this term over to one side, and we get this result. Next thing I'll do is I'll divide through by dx. So dividing both sides through by dx, we get this result. And then I'm going to divide everything through by the partial derivative of the utility function with respect to good y. And we have an expression for the slope of the indifference curve. So the slope of the indifference curve is minus the partial utility of the utility function with respect to x divided by, well, the marginal utility of good y. So the slope can be thought of in terms of the ratio of the marginal utilities. Let's do an example. Here we have a utility function. Looks like this. And we want to find the slope of an indifference curve where x equals 10 and y equals 8. So getting the partial derivative utility function with respect to x, we get y plus 4. Partial derivative utility function with respect to y, we get x plus 2. And as we saw on the last slide, the slope of the indifference curve is just minus the ratio of the marginal utility of good x over the marginal utility of good y. Now we're just going to plug in our values for y and x that were given up here. Y is 8, x is 10, and so the indifference curve at this point, the slope of the indifference curve at this point is minus 1. Okay, I hope you found this video helpful.